we're going to be looking at here how to solve some systems of equations algebraically. You may have in the past looked at how to solve them by graphing, where you graph the two lines, you look at that point of intersection, and use that to get our xy coordinate. And remember, solving a linear system means what is the x and y value that works in both equations. All right, what are the combinations of x and y that will make both equations true? Okay, so we're going to look at how we can solve this algebraically. Now the idea here is we want to do a little substitution. So I want to take one of these equations and I want to solve it for one of the variables. You really have four options. I could solve the first equation for x, or the first equation for y. I could solve the second one for x, the second one for y. What I want to do is pick the easiest one to do. Okay, so what I notice is in the first one, that doesn't have a coefficient. It's just x. So all I really need to do to solve that is get rid of the minus 3y or the negative 3y. So I'm gonna do that. That to me is the easiest one. It requires the fewest steps. So I'm going to solve this for x. Now when I do that, all I simply want to do is add 3y to both sides. And just a reminder, negative 6 and 3y are not like terms. You can't combine those together. So I end up with x equals 3y minus 6. Okay. Now what I'm going to do is I'm going to take my second equation and I'm going to substitute. So I'm going to take out my x. I just found out what x is equal to. So I'm going to take out my x. Instead of x, I'm going to put that 3y minus 6. Okay, it's multiplication, so we want to put that in parentheses. Plus 3y equals negative 3. And then I want to go through and I want to solve this. So do your distributive property here. So it'd be 6y minus 12 plus 3y equals negative 3. Right, I can combine like terms here. 6y and 3y make 9y. Minus 12 equals negative 3. Add 12 to both sides. I'm going to come over here, give myself some more room. So I've got 9y. That cancels out. Negative 3 plus 12 equals 9. And then 9 times 1 is equal to y. So I know my y value is 1. Okay, now I need to figure out my x value. So again, I'm just going to take one of my equations. Doesn't matter which one. I'm going to take the second one. Actually, I'm going to take the first one. That'll be easier. And I'm going to plug in my y value of 1. So x minus 3 times 1 is equal to negative 6. Well, 3 times 1 is 3. And then to solve that, I would add 3 to both sides. So x would be equal to negative 3. Okay. So I want to write that as a coordinate. So x value is negative 3 and my y value is 1. Okay. If I wanted to do, I could do a quick mental math check of that. Take my first one, x is negative 3. Get rid of this here. Let's do a quick check just to show. This would be a good thing if you had your calculator. You could just punch these in on your calculator too. There we go. So let's just double check, make sure this works. So say negative 3, 1 is my solution. So x is negative 3 minus 3 times y. Y is 1. It's negative 6. 3 times 1 is 3. And negative 3 minus 3 is negative 6. Right? So we know it works in the first one. Let's try the second one. 2 times x, 2 times negative 3, plus 3 times 1. It's negative 3. 2 times negative 3 is negative 6. Negative 6 plus 3 is equal to negative 3. Negative 3 equals negative 3. Run out of room there. That checks out. Okay, so I know that's my solution. Okay, so just to recap, all right, I solved for one of the variables. You can see that right here. Okay, and I erased the other part, but then you just, once you know what the x or the y is, you plug it into the other equation. Right, I substituted the x for 3y minus 6, solved that for y, figured out y was 1, put it back into the equation to solve for x. Okay, and again, your answer is a coordinate, so we want to write it using our parentheses, separate your x and your y with your comma. All right, but that is solving a system of linear equations algebraically.